Hi everyone, this is Tom and I'm coming to you in spirit from the Cradle of Aviation Museum, but in fact from my apartment. As you all know, we're closed, everything's closed, but that doesn't mean our jobs end. So my job today is to give you a short science demonstration. And we're going to use materials that you can probably find around your house. This demonstration is about density, buoyancy, and the materials you're going to need are a bottle that's almost filled with water, another container, pourable, that has some water in it, enough to top off said bottle from before, a packet of soy sauce or duck sauce or anything like that, a binder clip, maybe a smaller binder clip or paper clip, something like that. One of those things. Actually, a couple of those things might be best. We're going to use those later on. And a cup or glass of water that is taller than the soy sauce packet. All right, so have you ever tried to hold a basketball underwater? It's hard to do, isn't it? You push it down and it feels like it's pushing back up at you. Well, it's not actually the basketball that's pushing back up at you. You see, when you put that basketball beneath the surface of the water, you're moving aside a basketball-sized bit of water. And that basketball-sized bit of water that you push aside is pushing back. And it weighs a whole lot more than the basketball. So, if you let go of that basketball-sized piece of water pushes back in and pushes the basketball up and out. Now, if you put a bowling ball into the pool of water, about the same size as a basketball, you put it in, it's not too hard to hold a bowling ball under the water, is it? No, it sinks right to the bottom. And that's because the bowling ball weighs more than the bowling ball-shaped bit of water that it pushes aside when you put it into the water. So the water can't push it back up. The water's still pushing on it, but it can't push it back up. The bowling ball sinks to the bottom. Now, this is how ships float. Ships push water out to the side, the water pushes back on the ship. It's called displacement. A lot of times when you talk about ships and how much they weigh, they'll talk about displacement. It displaces this many tons. Well, today we are going to displace some water, and we're going to play with buoyancy, with density, using these materials that I said before. Now, this package of soy sauce right here, I'm going to hold it up to this camera over here so you can see it a little bit better. This package of soy sauce, it has the liquid in it, which has water in it, but also other stuff in it. That makes it more dense than water. But this packet also has air, and air is less dense than water. That's why the air is up here and the water's down there. So, if we put this packet of soy sauce into this container of water here, it floats. Even though the soy sauce itself is more dense than the water, the overall density of that soy sauce packet is less than water. Or, the soy sauce packet size bit of water that it pushes out of the way weighs more than the soy sauce packet. It pushes it back and it makes it float. Now, we're going to create a situation where this soy sauce packet barely floats. And we're going to do that by adding some weight to it. And that weight is going to come in the form of a binder clip. All we're going to do is place a binder clip on the bottom of it and place it back in. Now you see what happened there? Our soy sauce packet sank. So overall, the soy sauce, the air inside of it, and that binder clip, when you put it all together, it's more dense than the water around it. It weighs more than the water it displaces, so it sinks. So we might need a smaller binder clip to have this thing still floating, but not as high. We're going to put this red one on right here, this smaller one, and let's see what that does. Oh, look at that. It's floating, but not as high as it did before. Let's try that with another package of soy sauce. We'll try this one here with that bigger binder clip on it. We'll drop that in. Oh, that's sunk all the way down to the bottom. That's no good. How about this one? We'll try this little paper clip here. My cat George is coming over to help. He's really helpful. Let's put it in. Oh, that's what we want. Take a look. Do you see how they're both floating, but this one here is floating a little lower in the water? We want that. We want that to just barely be floating in the water. We want it to be close to what we call neutrally buoyant. If something's positively buoyant, it floats. If something's negatively buoyant, it sinks. When something's close to neutrally buoyant, it just kind of hangs out where it is. Now, this soy sauce packet here is positively buoyant. It's floating, but it's not as buoyant as the other one, and that's important. So, we're going to take this soy sauce packet, and we're going to place it into our bottle. And as expected, it floats. Now, we're going to fill up our bottle the rest of the way. In fact, we're going to fill up this bottle so that we get a little bubble of water on top, like that. The reason why we want that bubble of water on top is because we don't want any other air besides the air inside of that soy sauce packet in there. And now we close up our bottle. You will dribble water out the side, don't worry, it's normal. And then we think real hard. It sinks. What just happened? Well, that's kind of weird. What's going on has to do with all we've been talking about so far. Water does not like to be compressed, and I'm compressing this bottle. Now, like I said, the water can't be compressed. I'm not strong enough to do that. The only thing in there that can be compressed is that little bit of air that's at the top of that soy sauce packet. In fact, I'm going to bring it over here, and I'm hoping that this comes out, but when I squeeze it, do you see how the air bubble in the soy sauce container gets smaller? The reason why it does that is because I squeeze the bottle, the water squeezes the packet, and the air gets more compressed. You have the same amount of air in a smaller volume, the smaller amount of space. That makes the air inside of that packet more dense. The more I squeeze, the more dense the packet becomes, until it becomes more dense than the water around it. When I release the bottle, it goes back up again. Now, I'm going to try to make our packet neutrally buoyant. We're going to see if we can get it right into the middle there. Pretty cool, huh? Now, make one of these yourselves. Just make sure that you leave all the water you can in this bottle. You don't want any water below the lip of the bottle because you don't want an air bubble in there. If you squeeze this and there's a big air bubble at the top of the bottle, you'll compress that air bubble, and that's not going to help your diver. This thing is called a Cartesian Diver, named after Rene Descartes. I think I said that right. It's French, you know. But